Good morning friends, myself Dr. M.H. Chennaiya. In this video, we are going to derive an expression on the chapter design of keys and the subject machine design. Let's see what the question we have for today's video. The question reads like this: from fundamentals, determine the expressions for torque transmitted by a key in shear and compression. This is a basic equation that every student should know while designing a key or a coupling. Friends, in the figure I have drawn here, I have shown a shaft of diameter D transmitting a torque mt through a key having width B, thickness H, length L. Here, half the thickness of the key is inside the member and half is projecting outside. Now, let us see how to derive this equation. Friends, you know, a key generally fails by two methods. One is by the shear of the key, wherein the key gets cut along this cross section. So it will have an area B into L, the area under shear. Or it may fail by crushing while transmitting the torque mt. That is, this portion which is inside the shaft over a length of L will fail by crushing. So we will write down the expressions for both the torque transmitted by the key in shear and also in compression. So we will take, first of all, mt means torque transmitted by the key in shear while failing in shear is equal to the shear force, I will say Fs, multiplied by what is called the radius of the shaft, or the distance between the center to the top of this. Friends, what is this force, shear force? If you know area under shear multiplied by the shear stress of the material of the key, you will be able to find out this Fs. That is area under shear multiplied by shear stress is this value Fs multiplied by the radius of this shaft is diameter by 2. So I will say d by 2. So this can be rewritten as, friends, area under shear is this area, width into that length. So we can call it as B into L is the area. Shear stress is represented by tau. Since it is for key, I designate it as BL tau K, where tau K is the shear stress in the key multiplied by D by 2. And finally, friends, we can write down that is mt key in shear is equal to BL tau K multiplied by D by 2. Say, we will call this expression as expression number 1. Similarly, friends, if you consider the failure of this key by crushing, let us see what happens to this equation. So we are going to have a similar equation for the key under compression or crushing. So I will say mt key in crushing or compression, the equation for torque is F crushing, Fc you will say, is the load under crushing multiplied by the radius of this shaft. So Fc crushing load. So if you know what's the area under crushing, if you multiply that by the crushing stress or the compressive strength, you get this value. So I will say here, it's a product of area under crushing multiplied by compressive stress or stress under compression, compressive stress is this value Fc, that is multiplied by radius is d by 2. Very fundamental equation. It's not a big expression. So this is area under crushing. See the friends, see the board. The area which undergoes crushing is this area, that is thickness by 2 into length. So I will call it as h by 2 into length is the area under crushing multiplied by the compressive stress. I designate this compressive stress as sigma c multiplied by d by 2. So friends, this is another important equation which we use while designing a key used in any type of coupling. So you can say empty key in crushing is h by 2 into L into sigma c into d by 2. These are the two basic equations which you have derived from the fundamentals, and these equations we are going to use in the design of any type of key, whether it is a rectangular key, a tapered key, or a square key, whatever it may be. These are the two expressions we are going to use. Friends, please go through the complete video, and if you like this video, do share this with all your friends without fail. Have a blessed day.